family building as a model that could be repeated throughout the building and throughout the city. And this is the neighborhood of Prospect Park South in Brooklyn. And it's an area where you can see there's a lot of buildings of this building type. Pre-war, 6 to 8 stories, masonry load-bearing buildings with big roofs that would be great for solar. And so how do we retrofit these types of buildings? There's 3 approaches you can take. One is to retrofit from the outside with, you know, a panelized system or exterior insulation. And there's a lot of people doing great work retrofitting buildings with tenants in place by doing everything from the outside. But a lot of building owners aren't ready to undertake a project like that. And then the other approach would be to do it from the inside, but do the whole building at once. And it almost never happens that buildings like these are vacant and available to retrofit. So the third approach is to do it 1 unit at a time when landlords and rental buildings, when landlords have tenant turnover and they need to update kitchens and bathrooms and renovate, or in co-ops and condos, when things need to be upgraded. And co-ops could have building standards in their alteration agreements that require certain techniques, you know, when apartments are renovated. And over time, it's a path to get there. So this is the building on the corner of 18th Street and Albemarle Road. It's a 3rd floor apartment, so right here. And as you can see, the retrofitted apartment doesn't really stand out other than you can notice the different windows. And there's 2 small penetrations in the brick for the HVAC system, which I'll talk more about later. And the facade on Albemarle Road is south facing, and some of the biggest windows are on that facade and has a great tree for shade. And then the other facade is east facing. So this is the plan of the building, and this is the unit in the corner circled in green here. This is the existing and proposed floor plan. So the typical pre-war apartments have large bedrooms and living rooms, but very separate kitchen areas. And it was a 2-bedroom, and my clients wanted to fit in 3 bedrooms plus a flexible office space. So it was fitting a lot into a small footprint of 1,300 square feet. But, you know, we made it very efficient and made a more open layout with a more open kitchen. And it was important to keep views through to these 2 nice street trees that I've shown in green on the plan. So this is the space after we gutted it. The apartment was in very bad shape, so it really needed a full gut anyway. So it was a great opportunity to do this type of a retrofit. And as you can see, the main structure is steel, but there's wood floor joist construction like you would have in a townhouse. And the walls are masonry load bearing. So this shows the exterior wall assembly through the process. The first photo on the upper left is the existing conditions. As you can see, it was in bad shape. Then we stripped it down to the existing brick and joists. We insulated at the floor and the ceiling. Even though we have neighbors above and below, we still insulated there because it did a lot for soundproofing, and it also, in the PHPP, it really improved our cooling load. Not as big of an effect on the heating load. And then here we have a liquid applied air barrier on the brick and IntelliMembrane at the ceiling. And then we did 3 inches of continuous rock wool insulation over the brick. And then an IntelliMembrane, which is a vapor variable membrane. And then 1 5/8 service cavity, which we put additional rock wool in the cavity. And then this is after our windows are installed. They're triple glazed tilt and turn windows from Icon Windows, aluminum. And then this is after the sheetrock was up. So this is my main wall assemblies. The main one was 3 inches of rock wool plus the 1 5/8 plus 1/2 inch sheetrock, but there's a few spots where we were really tight on space where we used 1.5 inches of polyiso unfaced instead of the 3 inches of rock wool, and then a few detailed spots where we only did the polyiso. Just a few details. We did polyiso at the corners to avoid thermal bridging at the party walls. We insulated the ends of the steel beams to avoid some thermal bridging there. And then just taping all of the plumbing penetrations. At the neighbors' walls, we just did the liquid applied air barrier and over the existing plaster. And there were some tricky taping conditions around the beams. So this is just showing the floor and ceiling where we insulated, and we were able to get, a lot of these buildings have, when they have a concrete slab, you get a big thermal bridge there, but here, because it was wood framing, we're able to get pretty good insulation all the way around. We also did a lot of soundproofing. We did a soundproofing underlayment at the floor and also sound isolation clips at the ceiling. So that combined with the air sealing and the insulation, the apartment is really quiet. And the neighbors below even noticed it during construction, like once that was installed, how much quieter it was with the construction noise. So the HVAC system is the Minotaur unit, which is a combined heating, cooling, and ventilation system. And the great thing about it for this type of project is no outdoor unit is needed. We just had to create 2 penetrations on the building. So the air intake is right here between these 2 windows, and the exhaust is here below the bathroom window. It was a little tricky figuring out where we could locate them, because we needed them to be 10 feet apart and 2 feet from a window. And based on where they worked out in the floor plan, we ended up doing them 1 high, 1 low. And that worked out pretty well. And we were able to get approval from the co-op for that. So here's the HVAC plan. So here you can see the intake and the exhaust coming. And then the unit, we were able to locate it over a closet, and most of the ductwork over the laundry room, because the ceilings are not particularly high in this apartment. So we really wanted to keep everything from lowering the ceiling. So we were able to centralize it and just have a few soffits. We ran it up between the joists above the kitchen. But the great thing about this system is you're basically compartmentalizing the apartment, and because you're sealed off from the neighbors and you have your own fresh filtered air, you avoid the transfer of smells and bugs and everything else. And most of these buildings this type of pre-war building has no mechanical ventilation whatsoever. To start out, the kitchens and bathrooms had windows, so there was really no ventilation previously other than opening a window. So in addition to the soundproofing, with more people working from home, the air quality is really a huge advantage to doing this. Here's some of the window details. So we wanted wood blocking anchoring into the existing brick, but I chose to locate it just at the attachment points for the clips instead of continuous, so that we could fill insulation all in between. And the typical windows on the building have aluminum panning as like a brick mold, and I put insulation inside of the panning as well so that the frame was insulated over the top of the frame. And then at the lintel, we used a little bit of aerogel batt insulation, because this is a real narrow point. You want to connect your interior insulation with the window. So that connection was pretty important. So here's showing we used the pressure treated wood blocking that was wrapped with waterproofing at the points of the clip attachments, and we cut those back later. And then we used some rigid insulation under the sill, but we used some little blocks of a Partel product that's a more dense product. We also used the Partel product for attaching the finishes, places where we need to screw in later. We used that instead of wood blocking. And then we used some waterproofing at the sill that was wrapped up later. This is showing how we insulated the panning, and here's the panning on the outside. And then the windows were taped to the interior air barrier on the inside, and they were also taped on the outside of the exterior brick. And this shows the little blocks of the Partel product for attaching the finishes, and all the other space was filled in with mineral wool or with the aerogel batt. So this was kind of a tricky corner. This was the existing window above, and you can see we replaced it with one large window to get a better view of that tree and better solar heat gain from the south in the winter. And it's nicely in the summer, in the winter, and it's nicely shaded in the summer by that tree. But to get this corner to work, we had to use a thinner wall assembly. That's where I used some of the polyiso. And only step it back a little bit here in the corner. And then we also insulated the wall intersecting with the neighbor to avoid some thermal bridging at the corner. This is our blower door test. We hit pretty much on the first try. We hit 0.9 ACH50, which is below Retrofit. And that's tricky to do in such a small volume because it's 1,300 square feet and only a little less than 8.5 feet high. So it was thanks to a lot of patience that we hit the number. You can also see here the air barrier at the floor was the plywood subfloor, which we taped at the joints. So here's where we are now. We're just finishing up the project. And this is showing that view through to the big window of those trees and the view through the kids' bedroom there. So that's it. Yeah, and just to summarize, a lot of the advantages of this are, you know, getting rid of the window AC units, getting off the steam heat, the air quality and the soundproofing. And in this particular building, the co-op owns a lot of the units that they rent out. So the idea is that this retrofit can serve as a model that can be repeated when the